Hello, everybody. Thank you for coming to my talk on bootstrapping your invention side gig. There's been a lot of stuff sort of in the same sort of theme around, which is awesome. Really good to see. This one's going to be probably a little bit different, more tilted towards sort of how to do it on the cheap, and kind of sharing a little bit about my adventure too. So who am I? My name is Ben Hencke. I'm the wizard ElectroMage behind PixelBlaze, which hopefully some of you have heard of. I have a software background primarily. Electronics was a hobby of mine until more recently. In 2016, I switched from a full-time job to consulting work and focused more on electronics, kind of teaching myself all the things that I had missed out on or filling in kind of gaps, that sort of thing. I've always really enjoyed that, really wanted to invent stuff, really wanted to create new devices, not just virtual, just software bits floating around in a computer that you can't see, but actual physical things. PixelBlaze started as a weekend project. It was just sort of a hack to see if I could make this thing happen. Can you live code LEDs? And with a little bit of encouragement, I ended up polishing it up a little bit, writing a getting started guide, and threw it on Tindy in 2017. The very first version wasn't cheap. It was for the BOM cost. It was actually fairly expensive. And at that point in time, it didn't have a ton of features, but people still really enjoyed it and people still really liked it. And that success sort of built upon itself. And it was a surprise to me. It was kind of a shock. It was an experiment that, I was hoping for this outcome, but I wasn't necessarily expecting it. So it was awesome to see that. And I've continued to grow up from there in my spare time. In 2020, I started focusing more and more on PixelBlaze. I invested in a pair of pick and place machines so that I could do the assembly and stuff myself. I'd started off just sort of tweezering the first handful that I sold on Tindy. Just paste, stencil, one board at a time, tweezered the little resistors and stuff on there, and grew it from there. Eventually getting a low-cost pick and place machine, and then another one, a reflow oven. And automation tools and stuff to keep up with the demand. Teamed up with Crowd Supply for the V3 launch in 2020, which was awesome. It was a great experience. And now I work on this full-time. So this is my full-time job. I've downscaled pretty much all of my consulting work, and I spend most of my time on PixelBlaze related things, growing that business, the product, helping out the customers, and that sort of thing. And I make, ship, and support thousands of boards every year. So if you're interested in starting an invention side gig, first you have to become an entrepreneur. And the key thing about this is motivation. Like, why would you want to do this? Why would you want to turn something that's otherwise a fun hobby project into a business, into your job? Like, seriously, why would you do this? And as part of that, you have to kind of sort of filter it out into, is this a hobby project or is it a product? And one kind of simple thing that you could use to sort of help decide whether or not this is one or the other is that most folks won't buy a project. They'll buy a product, something that helps them solve the problem that they have. But they aren't necessarily, not all of us, some of us obviously are, but a lot of people won't buy something where it just needs a lot of work. They're interested in using something in order to achieve some other goal. So my first piece of advice for this is don't quit your day job, or do. If you know that this is right for you and this is the right time and you have the financial security to dive in and do it, by all means, go for it. But you don't have to. You can start small. You can start as a nights and weekends kind of thing. You can keep your regular day job and sort of grow from there. Transitioning more into this as it takes off, or doesn't. But really, do what's right for you. But don't expect it to be an overnight success necessarily. Something that you could quit your full-time job and then a month later you're making back the same kind of income. It probably won't work like that. It might. You'd be lucky, but it probably won't. Selling a product means product development. You have to take this thing. Not just a project or circuit board or something that you could use personally, but something that someone else can use, again, to solve some sort of problem, but also give them the tools so that they can use that. You have to kind of put yourself in their shoes, understand where they're at, what their how would they be using this thing? What would they be using it for? And keep in mind that, there's going to be a wide variety of expertise and knowledge and that sort of thing. So you have to kind of understand a little bit more about that and treat it more of a product. And there's a lot of stuff that goes in product development. You're going to want to test your idea before you invest it. This is, again, if you don't have a ton of money. If you want to just buy, tens of thousands of dollars worth of equipment, you don't need my permission to go and do that. But if you don't have that kind of budget, what you want to do is you want to look to test your specific idea to see if there's something there that's worth investing so that you know that you're going to get your return on investment there. Again, this is sort of with the budget conscious kind of focus. So proofs of concept, barely working versions are really great. They can help identify if there's something there, something that's worth spending more time and resources on. Lean manufacturing and lean software development methodologies are also really good and can help you there. Most of the PixelBlaze boards that I built were sort of built on demand. I didn't have a huge stockpile of things. And there's a couple of different ways that you can do this, but it gets kind of tricky between going to like a CM and getting really high volume discounts and just sitting on, tons and tons of inventory versus sort of a leaner manufacturing where I'm building the boards just in time. I might have a batch of the PCBs, and when supply shortage was around, I would buy massive amounts of chips just to have the stock. But I could revise that design. I could tweak or change things. I could adjust as necessary. I didn't have a huge backlog of stock that I had to work through because I was building these on the fly and making changes necessary. And you don't need to invest a fortune to get started making and selling at least circuit board type products. And even to some extent, plastics, with some of the 3D printing services, you could, print a lot of stuff on your printer and kind of scale that up through some services before you go and invest, thousands of dollars in injection molding and things like that. And you definitely want to refine and iterate. So keep in mind that once you build something, once you release it into the world, you're going to start getting valuable feedback, and you want to iterate on that. Take in and solicit user feedback. How is this working for them? What pain points were they experiencing? How can you make it better? You probably have some idea of that, but if you treat this more of an evolution of the product as opposed to I designed it perfectly from the very get-go, I spent years and years and years on this, and I released it to the world. It's much easier to have a successful product if you do that in smaller steps and iterate on it. More about product development. Unfortunately, it's more than just designing something that's cool. If it was just that, there would be a whole lot more products out there in the world. Part of this is market research. So who will be buying this? What needs do they have? You want to get, again, prototypes in people's hands and get that early feedback proactively. Again, plan to release it early, probably earlier than you're comfortable with. And this is it's a hard, happy place to find between, something that you're proud of, that you feel confident that somebody can use, and something that you've only spent enough time on in order to get it to the point where you can get it into somebody's hands and get that early feedback and iterate on it, make the next version better. You definitely don't want to hold it back until it's perfect, because that can become incredibly expensive, not just in terms of like how much investment you have in that specific design, but also just the amount of time that it takes. And to some extent, once we build something a certain way, we become sort of attached to it. It's not an experiment anymore. It's like, no, this is what it's supposed to be. And if you find that reality is a mismatch with this, it becomes harder to let go of those things that are not necessarily a good match when you've spent a massive amount of time on those things. Again, extra features can be added later. You just got to make it just good enough. The minimum viable product is definitely the hardest line to draw. This is another small piece of advice is that early mistakes are usually less expensive than the time it would take to prevent all of the mistakes. So you could potentially spend, months or years perfecting and going and making sure that you've covered every possible corner case to make sure that you haven't released this product with any mistakes. But chances are there's still some in there. It's impossible to kill every bug. But those early mistakes are usually less expensive. If you make something good, make something reasonably good, but not necessarily perfect. Get it out there and get that early feedback and fix those bugs. Fix those bugs early. Overall, you'll have spent less time and resources and energy in creating the end resulting product, and you'll have that feedback earlier, which again is super important. This is something that I've really been, drilled in on these last couple slides, but it's super important. Again, lean plus happiness. So I kind of take the lean principles, right? So don't do anything that doesn't add value to the customers, or add value that customers are willing to pay for, unless it makes you happier. You have to have some quality of life here. So if it's making your job easier or you're happier, add that as well. Marketing is super important. You have to understand, more about your customers. What is in the market? What kinds of things might people be comparing this against? What are the price points? What already exists out there? So when I built PixelBlaze at first, there was sort of the very, very low end of these cheap LED controllers, just being pumped out by China, you could get for like $20 or something like that. And then the really high end stuff used, for like VJ, stuff in venues that are hundreds or thousands of dollars. And there really wasn't a lot in between. There's a lot of do-it-yourself type stuff. So there's great stuff out there with Arduino, and fast LED and things like that. But there wasn't really a good ready-to-go product that you could use, other than these cheap LED controllers, which honestly the LED patterns totally sucked on. So I ended up pricing just slightly above that. And part of that was just doing all that market research and kind of understanding where this worked. And so I had to find an intersection between what I thought the market was willing to pay for and also what was worth my time, right? So again, I have a BOM cost, which in PixelBlaze's case wasn't massive, but then the amount of time that I was spending, especially in the early days, the very first versions that I was building and putting on there, so I'm manually tweezing, like parts onto this board. I have to count my time for that, for it to be worth my while for that. And so the original PixelBlazes were actually fairly expensive compared to their BOM cost or what you could get, in an Arduino, dev board, category of cost. But the product solved a problem for people, and people felt that was valuable, and they ended up buying it. And so I could keep working on it and iterating on it and making it less expensive and making it easier for myself as well. So here's some of the tricks, some of the stuff that I've learned along the way, which may be helpful for you. Again, this is tinted towards not a huge amount of capital investment up front. There's a lot of tools that you can use that are perhaps surprisingly inexpensive and effective. The first thing I would say is go surface mount, because you'll be glad that you did. And when you switch to automation, this is really sort of the way to go. So if you are like I was at a certain point in my electronics hobby project, working with through-hole components and things like that, they're not very easy to automate. There's a lot of extra work that goes involved in those, whereas surface mount technology is a lot easier to scale up. A hot air rework station was definitely one of the first tools that sort of unlocked that whole world for me. And I'm going back years and years and years. Many of you are probably already using surface mount components, but for anybody that isn't, trust me, it's a game changer. Definitely check it out. Once you go to any kind of scale or production, you can use something as simple as a $30 skillet for cooking and reflow like 200 by 200 millimeter boards or panels like at a time. And this is what I was doing with PixelBlaze for at least a year. And it can work. It's not the best. You have to keep an eye on it. It's very, labor intensive. So you basically put your panel down on here, you crank it all the way up, and you just watch the solder reflow. And once it's all cooked, you turn the heat off, you blow on it, you cool it off, and then you're good to go. You're done. There's no scientific, not even the microcontroller measuring the temperature curves or any of that kind of stuff. Just simple eyeballs and $30. But that was enough for me to build 25 PixelBlazes at a time and crank them out. Soldering equipment, there's just a ton of really good soldering equipment out there. If you just need like an iron or something like that, like the Pine Sol is great. Those $100 Hencke soldering irons are awesome. Just a little side for solder. Chip Quick is okay in a pinch. They sell it in small jars, which is okay, great for getting started. Once you get into larger volumes and you can afford the GC10 stuff, it's freaking magic. Like, it's amazing. Like, no more solder bridges ever. The stuff's shelf stable. You don't have to refrigerate it. You could just like leave it in stencil for like 3 days at a time. It's I don't know what it's made out of. It's magic. But tweezing and doing these kinds of things one at a time it's labor intensive and it gets boring. And once you get to a certain scale, it's time to automate and go from there. So this is a pile of the first PixelBlazes, the first set of PixelBlazes that I had manufactured through a contract manufacturer, a small batch assembly. Which is a great service, fairly reasonable prices, local in the US. You buy all your parts, you ship it to them, and you give them the data sheet so that they can program in their machine and stuff, depending on like the tape orientation of the components and stuff like that. Turnaround time was about a month from when I had shipped the stuff out until they were able to complete the boards and send it back. There's a lot of extra logistics in that. You're going to need to buy and source the parts, do a bunch of shipping and labeling and stuff like that. But they're awesome to work with, especially since that was the first time, manufacturing any kind of boards of quantity. Having somebody that I could actually talk to and who would, give some advice and, like, hey, there's a problem with this, but we can fix it and go from there, kind of thing. Overseas contract manufacturers are often cheap, but pretty difficult to get started with because they're not going to give you a lot of feedback. So you can expect some sort of trial and error there, and sometimes very expensive mistakes. So for example, JLC PCB, in my experience, will sometimes just totally mess up and then not own up to it at all, not really help you out at all for any of this kind of stuff. On the other hand, you can potentially go to their website, upload to BOM, kind of orientate some parts and get some stuff done fairly cheap. Just mind, once you hit a certain limit of volume, at least in the US, we have de minimis tariffs of $800. So anything that's going over $800 is going to get a 25% added bonus tax, which really sucks and can be a surprise and can be a really nasty surprise if you're trying to control your margins, especially on a higher volume product. And of course, in the other option, which is fun to see Hesden and Bride's talk on the pick and place for life choices, you can become a manufacturer yourself, which is what I did. I bought my first pick and place, ended up being around $5,000. It was $2,700, but then the shipping and then the tariffs that got added on top of that rounded up to about $5,000. These things are like finicky 3D printers. I expect to give it a lot of tender loving care and a lot of eyeball and a lot of tweaking and tuning and just making sure that it's doing something right. You're going to want something with at least feeders and vision. So the charm high that I have has something called drag feeders where the head will go over, stick a pin and move the tape a little bit. It's got a ton of those because it's basically just like cut out CNC bits out of an aluminum block as opposed to like a very fancy like electronic feeder. So it's not high cost, but the switch time of components is very high. So it takes a lot of time for me to kind of feed the tape through. It's not great if you're changing stuff out quite a lot, but at the very least, you want some kind of feeder system. There's some lower cost pick and place machines that have like little cut strips that you can load in there. And those are probably okay for prototyping, but I wouldn't even bother with any kind of production, any kind of volume production. I'd tweeze it, use a contract manufacturer or go the next step up so you can actually crank out a lot of boards. Just to give you an example just of speeds, the charm highs that I have a pair of them now, and they can place around 2,000 to 3,000 components per hour. So together I'm sitting at like 4,000 to 6,000 components per hour if I can run these things in tandem. Whereas the other ones that are perhaps very precise, but they're incredibly slow, would become very tedious to watch for any kind of volume production. So while the charm highs are limiting and a little finicky, they're built for speed. Couple of benefits to this, it makes it a lot easier to prototype. So if I have a new design or a variation, I've already got the parts loaded in the machine. I can get an export of the position information from my CAD software to the machine in a couple of minutes and just spit out a board. And sometimes what I'll do is I'll have it populate all the stuff that I already have loaded in the machine, and then just kind of tweezer on the next couple of things for my prototypes. But it still saves me, tens of minutes just to go through that process. It does really help me understand the design for manufacturability aspects. It's something that I heard a lot about. And really, once you're manufacturing your own boards, you get a very much more enriched sense of what that means. So everything from the footprints, to the type of components that you're using, the pitch, spacing, how long those pads are, how you're going to rework the board, the spacing between all the components, all becomes like a much better, more intuitive sort of sense when you are doing the manufacturing yourself, and you can fix and understand those mistakes and sort of iterate on that for the next version. Where I found with the, for example, the contract manufacturing is sort of a black box. Even with the people that I could talk to, if there was a big problem, I could obviously, they would say, hey, there's a big problem, we can work through this kind of thing. But even for the little stuff, like if the pad was just a little bit extra longer or not long enough, or, just the heat reflow profile of, like, for example, the ESP, thick ESP modules on top of a circuit board sort of thing. You get a much better sense of these things when you're the manufacturer yourself. Of course, this is more for you to learn and understand and kind of tinker with, but it's right there, and you can see and experiment with it. This takes a lot more of your time and space. So this is not necessarily something that you'd want to do unless you have the time to invest in this sort of thing. And the pick and place machines, I mean, they'll take up, a huge chunk of space, even the small desktop ones. Right, so program and test. So assuming your board has some sort of microcontroller or something on there that you need to load some firmware on, or has some functionality that you want to automatically test, it depends a lot on your product, but I would say it's not worth automating until you have some volume. It's possible to manually test just a handful of boards that you're doing this in the nights and weekends kind of thing. Once you start to build up that volume and you're dealing with a lot of these things, it starts to make a lot more sense. So when I started with the Crowd Supply campaign with version 3, I started with the image here on the left, which was just a single pogo pin programmer. And this is nothing super fancy. This is, you can't really see it from the image, but I just took a perf board and I soldered some pogo pins in there very carefully with some tweezers. And it was good enough to program in the, several hundred PixelBlazes that went to Crowd Supply, and then the several hundred PixelBlazes that continued to go to Mouser for stocking these things, as well as my own sales. Until, sorry, that should read 2022, not 2023. Last year, I actually sat down and I spent the time to design my own hat for Raspberry Pi, along with much better CAD for some 3D printed parts and stuff like that. So I could have basically a full set of Pogo pins for all of the pins and signals that I was interested in automatically testing, along with some other extra stuff. So I have like a polyfuse in there in case there's like a short on the power rail or something like that. So I'm not like hosing the Raspberry Pi. But I could also then treat this as a sort of mini product, and I could crank out 5 of these things. And so now I have this sort of mini production line of these Pogo jigs where they're done by the time that I can load the next one in, basically. So I can kind of keep this as a continuous production line with these things. But again, that wouldn't have made sense until I had the volume. There was a lot of time that I invested in designing those things. So that kind of gets into this. I don't know if you're all familiar with XKCD. This is definitely an amazing comic, but very, very informative chart here. So how long does it take to automate something versus how much time you do it manually? How much time are you going to save over time? And this chart is based on 5 years. I would say take that, at least go divide that by 5, because chances are when you're automating something like this, something is going to change. Within 5 years, you may not. You'll be working on probably a different product at that point in time. So you may not see the payoff there. You definitely want to keep that in mind on this. There are some cases where it might save you the headache or the pain of doing this kind of stuff manually. It makes sense to invest it, even if it's not going to pay you back in time. But generally, you want to be mindful of this. Support and documentation. So when you have a product that you're giving into the hands of customers, especially an open source product, open source software, hardware. The source is awesome. It's great. It's amazing. But you also have to provide documentation because not all of your users are going to be able to go and read the entire code base and understand how to use this thing. Documentation is super important. How are people going to get started using your thing? All these things will save you tons and tons of time and will help get your customers onboarded and happier faster. How do you handle the support Q&A time? So somebody gets your product, they start using it, they have a question. How do you handle that, that sort of thing? So keeping these sorts of things in mind is super important when you are trying to do this. Look for ways to double the value of support Q&A time. So when I got started doing this, I had a fairly minimal but getting started document that would walk you through all the basics of how to set this thing up, how to use it, and that sort of thing. But there's 1,000,001 questions that I can't possibly anticipate. And so I would get questions by email. I started saving those responses so that I could use those later. Eventually, I got a forum/wiki hybrid called Discourse and set that up and started directing all my users there for support questions so that I could answer there. And it becomes basically a Googleable, wiki, at that point. People can go search like, hey, how do I do X with PixelBlaze? They'll just find this, answer that I wrote some time back. And then I don't have to answer that customer's question. So it saves myself time, but also saves the customer's time because they can get that immediate answer to their questions. FAQs, docs, etc. One thing I started doing was inserts for the most common questions. So I sort of compiled in the basic, like, how do I hook this thing up? Well, go RTFM. Well, somebody gets something right in the box. They want to tear into it. They want to start connecting to it immediately, right? They don't want to go read a whole bunch of documentation on the website. So I started giving these little inserts with really basic how to connect this thing, how to set it up. And I found that saved a lot of time and definitely got people up and running. I use business cards because it's really, really easy to get inexpensive business cards printed. Not a whole lot of paper, so I don't feel bad, stuffing tons of manuals into packaging. It worked out pretty good. Right, selling. So the first part of selling is pricing. Pricing is hard. Pricing is incredibly hard. Key piece of advice here is you have to make it worth your time. So don't just look at, you have to look at the BOM cost. How much does it cost for you to manufacture this thing? And you'll see recommendations of like, at least 2.5, 2.7, 3x your BOM cost or whatever. And so that might be okay, but that's like a floor. You have to make it worth your time. How much time are you spending in your nights and weekends in your Invention side gig pouring into this? If you want to scale that up, it has to be worth your time. You don't want to scale something that's going to make you unhappy or that's going to be, not paying you for what your time is worth. And this is hard. Don't undersell yourself. It's really easy, especially as creators. We have access to, wonderful, dev boards and hardware and things like that to undersell your product or to value it, based on what you think the parts are worth, but not valuing it based on the product. And so it's tricky, but, might take a little bit of practice, but don't undersell yourself. Tindy is a great, easy way to start small scale. Very, very low commission. I think it's like 5%. And then you pay like a couple of percentage points for like payment processing fees and things like that. But there's no platform cost. You can list your products there and get started nights and weekends. There's tons of people that go that route. I definitely recommend it. And then there's Crowd Supply, obviously. Crowd Supply is great when you have, when you don't really know what your end product sales might look like. You have some idea, but you don't know necessarily, or there's some step function. Like let's say you need a plastic injection mold, and that's going to require a bunch of capital investment, things like that. And for me with PixelBlaze V3, I had V2 already running, but I didn't know how many people would be really interested in going to the next step up in the level, in a version 3. There's a lot of improvements, but am I saturated? Are all the people that would like PixelBlaze are already happy with the V2? How many people would really go for this V3? So it made a lot of sense to go a Crowd Supply route in that case. I was going to do it no matter what the result was because I didn't have any kind of step function. I didn't have some massive thing. If it was 50 people, I still would have done it. Fortunately, it turned out to be a lot more than that. Etsy is a bit of a trap. They have very high fees and commissions, random bans. Like I've heard nothing but horror stories from my friends who have sold on Tindy, or not on Tindy, on Etsy. That said, there's probably some niche products where that might be the place where your customers are and you have to live with it. But if you're just selling kind of circuit board type stuff or electronics, I would definitely stay away from it if you can. And of course, you're going to want to set up a low-cost direct payment taking system. There's a ton of ways that you can do this. So, for example, SquareUp was one of the first ones that I used. You can set that up, and you can start accepting, credit card payments and things like that. There's ways to do like online shopping and links and stuff as well. PayPal, of course, and many website platforms have their own sort of like store capabilities built in that you could leverage. Oh, and I'm missing a bullet point here. No, I'm not. We'll get to that later. So Shopify is the other platform that I wanted to mention, but that comes a little bit later because it is not very low cost. So for shipping, I would definitely recommend print postage yourself. You could save a ton of money doing this. It's faster than going to the post office, even for low volume stuff. Pirate Ship is a great resource for this sort of thing. So there's no fees to sign up, no monthly charges. They have discounted USPS and UPS rates, as well as a cheap international post option. It goes through Ascendia, I think, and they basically airmail it to customs in the other country and then use post for the rest of the journey. It's a little bit faster than USPS international and definitely a lot cheaper. But their USPS and UPS rates are really, really good. Once you kind of scale up and you're looking, to the point where it makes sense to have a Shopify store, the Shopify shipping integration stuff is really, really good. Same kind of USPS rates as well as DHL. It's very well integrated. So you basically one click and you have postage. When you have any kind of order volume, save yourself a ton of time and headaches and get one of these Rollo printers. They're amazing label printers for 4x6 shipping labels. Probably one of the best investments. Like I would upgrade that before upgrading my soldering equipment. Like it saves you so much time, so much headaches. And of course, you have to be mindful of the boring government stuff and CYA. So you're going to want to have some sort of structure, be it an LLC or an S Corp. You can also do this as yourself, but having a corporate structure gives you a little bit of protection. Insurance, you're going to need a broker to find insurance for manufacturing and selling. The typical, family insurance agents aren't really going to be able to help you there. You're going to want a reseller's permit. And so this varies quite a bit from state to state, but you need a reseller's permit. I haven't done this in Oregon, but in California and Washington, it's pretty easy to get started with a reseller's permit, and it can save you a ton of time and headaches. So for example, I got hit with a bunch of surprise sales tax on stuff that I had imported in California before I had a reseller's permit. So they saw that I had imported all these things and saw that I hadn't paid sales tax on it and sent me a giant bill with penalties later. It wasn't very fun. Filing taxes, local, state, and federal taxes gets more expensive, especially if you have a corporate structure of any kind. I'm not a tax person or can give you any kind of advice there other than you might need a CPA. It gets more complicated for sure. And then on U.S. import tariffs. Again, so stay under the $800 if at all possible. And this is per day for all of your invoices that you import per day. So if you have 2 shipments coming in at $450 each, and they arrive on the same day, you can get nailed with this, unfortunately. The other thing that I found out quite recently is that you can't really do too many tricks with this. So you can't say, order a larger batch of something and then have them just split it up into 3 shipments. It's based on the invoice. So really, my best advice there is to split it up, order smaller segments if you can. If you can't, you end up paying tariffs. Just build this into your cost model and be aware of it. And then I have a slide with a bunch of resources. These are things that I found helpful along the way. Osh Stencil is really good stuff for doing any kind of prototyping. I mean, I love them. Good stuff. Local CMs, again, are really awesome. Great place to start. Cyber City Circuits, they're amazing folks. They'll help you out. Small batch assembly, used them in the past. Really good stuff. Offshore PCB and CM, inexpensive, but again, mind the tariffs. JLC PCB is cheap and fast, but will sometimes mess it up and leave you hanging. I've had this happen a lot. I have like 100 pounds of PCBs that I can't use from various runs that are just bad for various reasons that they are basically not going to give you anything for any of that kind of stuff. Don't expect it. On the other hand, they're cheap enough that it makes sense still economically. Just be prepared for some of the stuff to get messed up and that you'll have to reorder. PCBWay, I've used them as well. They're higher quality for sure, but they're a bit more expensive. And PCB Shopper is another resource if you just want to sort of like shop around and see what's out there. It's a tool for just kind of like comparing prices for stuff. The Desktop Pick and Place Google group is a really good resource for people helping each other out with these low-end desktop pick and place machines. And of course, we have the Maker BizWiki. So I found this group about a year ago, and it's a bunch of maker hackers that also have these side businesses getting together and kind of helping each other. We have this wonderful, weekly video call that we all hop on and say hi and show off other cool LED products or talk about how we're going to source this thing. It's a really great group of folks. So if you're looking for other people that are sort of either just getting started or have more established maker businesses, this is a good resource. Also, I want to shout out to SparkFun's blog. They don't have a ton of stuff in recent years, but if you go back in the archives, there's a ton of really good stuff. Nate's posted about stuff. So for example, the skillet hack, I found that through SparkFun's blog. Nate, the founder of SparkFun, was like cooking, panels of boards using these things at one point in time. So I mean, you can definitely start there and grow. As well as some really good stuff on the desktop pick and place machines, and why, I think this was in 2018, why SparkFun would buy one of these desktop low-end pick and place machines when they had a $250,000 pick and place machine in the next room. It really let them iterate and get through to these designs and make these smaller batches faster, which was important for adapting and creating more products more quickly. That's what I have, and if we have any time left, I'd like to open it up for Q&A.